all right now. I'm going to start my today's
Now
session.
visible.
Yeah,
Now
okay.
sir, you are visible.
Yeah. So this is my 29th class on BSM 301. And if you go by the syllabus, you will find that if you count the number of classes that are actually um, given for each module, you'll find that the total count will add to 32. And in that case, we are almost, you can say that we have almost reached on the verge of completing the syllabus of BSM 301. And yes, it is indeed so. So we are in a position by which we can very successfully can complete this particular syllabus. But the completion of the syllabus will be only successful only if its course outcomes are achieved. And the students who are actually new to the ECE section, like lateral students, I have not yet decided about what to do with them. Later I'll think, because they probably have missed previous examinations, and many more are joining till now. And after that I shall decide something for them. But once I finish the class, if I finish the topic of BSM 301 by taking 3 or 4 classes, then do not think that I will be detached from you. You don't have to be worried about that, because you shall be in constant touch with one another, because CA3 examination has to be taken, CA4 examination has to be taken. And if there are doubts from students' end, then we can again arrange the class and we can discuss things. Okay, so officially I can, after taking 3 or 4 classes, I can officially complete BSM 301. Okay, that will be official completion, but unofficial class can be taken. So you don't have to be worried about it. And of 10 students, there are 10 participants. The participation is very poor today, but only 5 has written their roll numbers in the chat box. So others, please write your roll numbers in the chat box. Okay, my today's topic is on test of significance, and there I'm going to discuss a JET test and large sample test. Test of significances and hypothesis testing is one of the important topics of applied statistics, and is one of the important goals with respect to course outcome. And you see that yes, in my last class, that is 28th class, where I actually shared with you a page of the book of John Foynt. That was my 28th class. There I actually defined what hypothesis testing is. But what is test of significance that I'm going to define right now? A test of significance is related to hypothesis testing, and we can define it in the following way: that when you design your hypothesis, you design your assumption, then you are going to test your assumption on the basis of the sample. And you are going to test the assumption of what? You are going to test the significance of your assumption, whether this assumption can be rejected or can be accepted. That is your goal. And therefore, this chapter is called test of significance of the hypothesis that you have made. JET test, JET stands for the normal variate. So you will find that when I'll scroll down, you will find that the formula which I'll be using is aligned with the formula of the standard normal variate. If you can recall the formula of the standard normal variate, that is capital Z is equal to capital X minus mu by sigma. So all my formula below are aligned with it. Large sample test is actually corresponding to the large sample. So since these terms are there, first of all, I decided that I must tell you what large sample is. What is the definition of large sample? If I could have asked you what large sample is, you could have replied in different, you could have said, sir, large sample can be considered when sample size is 1,000, 10,000. When I talk about large sample, immediately these numbers come to our mind. But statisticians, after doing lots of mathematics or mathematical models based upon the mathematical models, they have decided that the universally accepted size or limit of deciding whether the sample is large or small is 30. So if the count of the sample is greater than that, if it exceeds 30, then it is considered to be large sample. And if it is less than that, we consider this to be small sample. Okay, please mute yourself. So if the count is greater than 30, it is large sample. And if the count is less than 30, it is called small sample. Okay, so do not ask me right now why the count is, why the limit has been set at 30, because a huge amount of mathematics is behind it and it is beyond the scope of our syllabus. So if I start discussing this, then I shall not be able to discuss other things which are there in the syllabus. Okay, please mute yourself. Students, please mute yourself. See what's happening? Yeah. Somebody has gone crazy, I think. Okay, so first of all, the Z test I'm going to discuss, it's called general testing procedure. General testing procedure. And first of all, I'm going to discuss what the general test procedure is. How to test your hypothesis. Step number one is that you need to define your hypothesis first, with the null hypothesis and alternative hypothesis. And please mute yourself. Whoever is unmuted, him or her, please mute yourself. The students are, we are facing, somebody has unmuted and has gone for sleep, I think. Okay, so just a minute. Okay. Ayush Raj and Maharshi Ishwar Jesraj, Ritesh Thakur, please mute her. Riddhim Sharkar, Ayush Raj, please mute yourself. Okay, so for the general testing procedure is that you have to define your null hypothesis H0 and alternative hypothesis as H1, and you have to set your level of significance at certain level, which is alpha. What was the definition of level of significance? The definition was, it is the probability of conducting a type 1 error. Okay, once the level of significance is set, you decide your null and alternative hypothesis. Then on the basis of the sampling distribution, you choose your appropriate testing tool or test statistic, and you decide your critical region or of the size, or you can say you can decide the size of the alpha or the level of significance. And on the basis of that size, and on the basis of the sample data, you are going to either accept your null hypothesis or you are going to reject your null hypothesis. Okay. One class on testing of hypothesis will not be sufficient to convey the idea to you in its full amount, because I have to take other, if we keep on taking but my further classes will be on hypothesis testing only, and there, after doing problems, lots of problems, you will get to know what it is already. So you don't have to be panicked what is written over here. Okay, so this is general principle of the general testing principle. Okay. Later, I have in the just below, you can see I have written a definition which is called p-value, but I am not going to read this definition right now. I shall come to this particular point later on, because in my today's class, I am not going to solve problems on the basis of p-value. Okay, so the problems which I'll be discussing in today's class has been solved in a particular way. Another way of solving the same problems will be the approach of p-value. And therefore, after defining p-value, I have mentioned the standardized testing procedure for testing the hypothesis. Where you can see in step number 4, I have mentioned about p-value. So you can read the definition of p-value from this particular note, or this there in the book. In tomorrow's class, I will be discussing p-value in details, but not in today's class. Okay, so let's move on, and let's discuss a particular case. If you have the syllabus with you, you'll find that the first there are several testings which has been mentioned in the syllabus. One of the testing is the testing of single mean. And that testing is and there are testing of single proportion, difference of proportions, difference of means. Many 5 different tests are mentioned in your syllabus. I shall start with tests concerning mean. Okay, let us see how to test this. So what we'll do first of all, we will read the question properly and we'll find what are they talking about? What is their assumed population mean? Is the population mean given in the problem? We shall identify that first of all. So mu stands for population mean, and mu naught is one of the specific values of mu which will be given in the question. We will treat this particular statement as our null hypothesis. Okay, every null hypothesis has its own counterpart. These counterparts can be written in terms of either mu not equals to mu naught, or mu greater than mu naught, or mu less than mu naught. Okay, now I am coming to this particular formula. The formula which I shall be using in tests concerning mean will be of this particular form. I said that these tests are called JET test because the formulas are aligned with the definition of standard normal variable. You see that the definitions are indeed aligned. The formula has been mentioned as Z is equal to X bar. In place of capital X, we have X bar. In place of mu, we have mu naught. And divided by, in place of sigma, we have sigma by root n. And you can say that this particular formula is exactly similar to the formula which was given in the central limit theorem. Okay, if you can recall that. So that central limit theorem is also a kind of playing some kind of role in testing of hypothesis. I'm coming to that point. Gradually, I'll come to this point. So we first of all decide our null hypothesis and alternative hypothesis. At this juncture, you can ask me one question: why aren't you selecting these statements as null hypothesis and that as alternative hypothesis? The answer to the given question is that when we test something, the test is conducted under the assumption of null hypothesis. So if you put these statements in null hypothesis section, say mu not equals to mu naught, or mu greater than mu naught, or mu less than mu naught, you shall not be able to put the values over here. So equality signs are always taken into consideration under the wing of null hypothesis. Other signs like not equal to, greater than, and less than are taken into consideration corresponding to alternative hypothesis. And this is the first. Second, we shall look for whether the sample size is mentioned in the question or not. You see here the sample size is small n. It is mentioned in the question. Size is small n. Okay, fine. And we shall assume that from the population from which the sample will be drawn, the population will behave like normal curve. We can assume anything. So that is one of our assumptions. If we do not assume this, we shall not be able to use this JET test because Z is the standard normal variate. So we shall assume our population with a normal curve. In COVID-19 situation also, the statisticians initially decided that the curve will be like normal, that the number of cases active will be increasing, and in the month of July and August, it will reach its peak and then gradually fall. But if you go by the newspaper or news channel, you'll find that the curve is not symmetric at all. It has become asymmetric to the positive side. Okay, probably you have seen it. So assumption, we can make any kind of assumption. There is nothing wrong about that. And if we are assuming that the sample which is being drawn from the normal population, then we have to assume another thing, that we have to make sure that we know the population variance. Population variance has to be known, because if the population variance is not known, then we shall not be, if sigma square is not known, we shall not be able to put the value of sigma in this particular formula. So to apply the formula, we need to know the value of mu naught, we need to know X bar, we need to know sigma, we need to know sample size. Then only we can conduct the tests concerning mean. We set our critical regions in this particular way. After calculating Z, sometimes we consider the absolute value of it, and we see whether the Z value at some level of significance is lesser than this absolute value or not. The alpha is your level of significance, which you have set initially before you start solving the problem. Or we can go for this. Sometimes we see whether Z is greater than or equal to Z alpha by 2 or not. Or sometimes we see whether Z is less than or equal to minus Z alpha by 2 or not. It is a matter of choice. The test will sell different tests corresponding to the different situations. We decide what to take, whether to take this or this or this. The most commonly used level of significance will be treated as alpha is 0.05. That means that you are considering that there is 5% chance that you are actually prone to type 1 error, or sometimes we consider this to be 1%. Okay, these are universally accepted level of significance. We do the statistical calculations on the basis of this level of significance. And if you consider your alpha at 0.05, then Z alpha, put in place of alpha 0.05, the Z alpha can be found as 1.645. Z alpha at 0.01 can be found as 2.33. And if you are dealing with alpha by 2, then for 0.05, Z alpha by 2 will be 1.96. And for 0.01, Z alpha by 2 will be 2.575. From where we are getting these particular values? From this statistical table, standard normal distribution table, the values can be obtained. And if you can recall that when I discussed the normal distribution in the in module 2, then I said that these are nothing but the areas covered by the normal curve, and this can be calculated. This can be calculated by numerical integration process. Okay, so should not be deviated from what I am teaching right now. So coming back to my original discussion, so these are the values, and if you ask me that whether these values has to be remembered or not, these 4 values you try to remember, because you can remember this, and we actually try to, just like you can remember the periodic table, then you can remember this also. You don't have to remember the entire table, but these values can be remembered. Okay, in Z test we shall be using mostly these. We shall be operating on the basis of these values mostly. Okay, too many theories have been discussed. Let's go back to a problem. Problem 1 is saying this. You read the problem 1. What is it saying? It is saying that suppose it is known from experience that the standard deviation of the weight of 8-ounce packages of cookies made by certain bakery is 0.16 ounce. To check whether its production is under control on a given day, that is to check whether the true average weight of the package is 8 ounces, employees select a random sample of 25 packages and find that their mean weight is 8.091 ounces. Since the bakery stands to lose money when true average exceeds 8 ounces and the customer loses when the true average is less than 8 ounces, test the hypothesis that true average is 8 ounces against its alternative at 1% level of significance. I have read the question faster, but if you read like me, you shall not be able to solve the problem. So your reading should be like this. Okay. See, I have highlighted some portions. Okay, this portion and that portion has been highlighted in green. This portion and that portion are highlighted in yellow, and these two are highlighted in pink. That has been done intentionally. Why? How to read the question. So you see, suppose that it is known from experience. That means what? These values 8 ounce and 0.16 ounce, these values have not been calculated, and since it is mentioned over here that it is known from the experience, that means these values are assumed values. So weight of 8-ounce package, true average weight of the package is 8 ounce, means they are talking about the population mean. Standard deviation of 8-ounce package of cookies is 0.16. That means population standard deviation of mean, and everything has been obtained from the previous experience. Okay, what is the sample size? They want to check it. They have selected a sample of 25 packages. So 25 is my sample size. So it is lesser than 30, and therefore it is not a large sample, it is a small sample. Z test can be used both for large as well as for small samples. Okay. Mean weight, their mean weight is 8.091. Their mean weight is 8.091, and this mean weight is not about the population mean weight. This mean weight they are talking is about the mean weight of these 25 packages. So this is sample mean weight. That means they are talking about X bar. Why do we want to select, why do we want to study this particular problem is because, see, the bakeries tends to lose money when true average exceeds 8 ounces. Why? Because if they are manufacturing the cookies, okay, and they are putting the costs on based upon the size of the cookies. So if the cookie size is greater than 8 ounce, if its weight is greater than 8 ounce, then, and if they are setting the cost on the basis of 8 ounce, that means they are losing money. And if suppose the cookie size is less than 8 ounce, then customer is losing, because customer is paying for 8 ounce cookies and they are getting lesser than that. So because of that, the production, the analyst in the production department, they have decided that whether their produced cookies are actually fulfilling the specifications or not. To check that, they are going to test the hypothesis whether their cookies are indeed of average size, average weight, that is 8 ounce. So in the solution part, they have set their null hypothesis as mu population mean, whose specific value is mu naught, and in this case it is 8. And if it is not 8, then whether it is lesser than that or greater than that, nothing is mentioned in the problem. Okay, so we are not sure about it. So in the alternative hypothesis, we have mentioned mu not equals to 8. Now mu not equals to 8 has two possibilities. Either mu is less than that or mu is greater than that. So two tails are open. Therefore, this kind of test is called two-tailed test. So if inequality is there in the alternative hypothesis, then we call it as two-tailed test. Okay. Level of significance or the probability of conducting type 1 error is set at 0.01. It is pre-decided. Okay. Because they are this for this kind of level of significance, the tabulated values are known, and we are going to compare our calculated value with the tabulated value to put our judgment. Now you have already got your formula for Z. This is the formula. You correspondingly put the values of X bar, mu naught, and sigma and root n. I have substituted all the values over here, and the value has come out to be 2.8435. Now, the section which I'm going to represent over here, this section is a kind of, what shall I say? This section is in the chapter of hypothesis testing. So if you read the chapter from John Foynt's book, which I actually shared in my last class, you will get to know about this particular thing. It is written that you know that from a real number theory, that if we consider Z to be a real number, and if mod Z is greater than equal to kind of real number, say Z alpha by 2, it implies that either Z is greater than Z alpha by 2 or Z is lesser than Z alpha by 2. This implies if we substitute the formula of Z over here, and if you do a little bit of, if we play with a little bit of inequalities, you will find that your X bar, the sample mean, will fall under a limit. The lower limit, the upper limit of that will be mu 0 minus Z alpha by 2 into sigma by root n. Its upper limit will be mu plus Z alpha by 2 into sigma by root n. So I have made a particular normal curve over here. Consider this point to be mu plus Z alpha by 2 sigma by root n, and this point to be, this point to be mu minus Z alpha by 2 sigma by root n, and this point to be mu naught plus Z alpha by 2 sigma by root n, and mu is there. This is mu minus this and mu plus this. This region is called the acceptance region. So your test value, if its value falls under this acceptance region, you are going to accept your null hypothesis, and if it falls outside this region, you are going to reject the null hypothesis. And you know that since it's this particular curve is talking about two rejection region. One is this and another is that. That means, and since the level of significance is set at alpha equal to 0.01, so it is mentioned here in this particular case that for alpha equal to 0.01, you can consider Z alpha by 2. The value of Z alpha by 2 will be 2.575. It is known. And why am I considering Z alpha by 2 and not Z alpha? It is because this theory. Because in this particular theory, we have considered Z alpha by 2. This particular thing will be considered in case of testing of single mean. For other testing, some other things will be taken into consideration. This is a rule which we have to keep in mind. Okay. Alpha could be 0.05 also. Then also we could have considered Z alpha by 2 in this particular case. Now, if it is the scenario, then we see that our calculated value of Z, which is 2.8435, is actually greater than, it is said that we reject our null hypothesis. The step number 3 is we reject our null hypothesis if your Z is greater than Z alpha by 2 or it is lesser than Z alpha minus Z alpha by 2. We find that our calculated Z 2.8435 is greater than 2.575. And therefore the null hypothesis must be rejected and suitable adjustment should be made in the production process. That means what? What is our conclusion? Now we are rejecting the null hypothesis, means we are rejecting that the average weight of the cookies is not 8 ounces. Previously, we thought that probably this 8.091, this result is only based upon 25 packages. And so if I take other samples, then everything will be aligned. Now we are seeing after doing this calculation that no, this is not the thing. Actually, the cookie size is being increased and we need to optimize that. If we do not do so, then we are actually setting costs for the manufacturer is setting cost for 8 ounce cookies and he's selling more than that. So the customers will be benefited, but the manufacturer will be the losers. So this hypothesis testing's conclusion will be put forward to the statistical quality control section and they will take the decision how to optimize their manufacturing process so that if the cookies they are making large size cookies or cookies with bigger weight, then they have to set their costs accordingly. Okay, so it is their department. They are going to decide it on the basis of the hypothesis testing. I know that some parts of this particular problem is not clear to you, but as the classes will progress and tomorrow I am going to take a class, then gradually you are going to get the essence of it. So don't worry, you just get to know how this hypothesis testing is being done. Okay. Second problem I'm considering, before that, there is a note for you and it is very important note. Let me read the note. When we are dealing with a large sample from a population that need not be normal, but as a finite variance, we can use the central limit theorem to justify using the test of normal populations. And even when the population variance is not known, we can approximate its value with sample variance in the computation of the test statistic. Such a test is called large sample test. Okay. Let us go slowly. Central limit theorem. What does central limit theorem say? Central limit theorem says, if you can recall, that when you increase the sample size, then your population, the distribution of the points is tending towards normal distribution. Okay, so for lesser number of samples, maybe the population is not normal. So in that case, what you need to do is that you keep on increasing your sample size to meet the specifications. So in this scenario, and if we know that population variance is known, but it is not behaving like normal, we can increase the sample size. So that is one scenario where large sample test is applied, or if the population variance is not known, then we can approximate this population variance with the sample variance. Now, why am I saying this? Because there is, as I said you, that there is a gap in your syllabus, and the gap is that point estimation. Please mute yourself. Please mute yourself. So if the if the population variance is not known, then we are actually guessing the population variance by sample variance. That is another scenario by which in which large sample tests are actually applied. If you ask me that whether population variance can indeed be estimated by sample variance or not, the answer is yes, but this has not been discussed in the class because this particular part of the topic is actually missing from your syllabus, and that is gap. So if you want to know about it, you have to go through the point estimation chapter of John Foynt's book. Okay, this is the gap of your syllabus. Coming back to the problem number 2, let's see what is happening over there. Suppose that 100 high performance tires made by a certain manufacturer, 100 high performance tires, 100 is quite large than 30. So this particular problem is talking about large sample problem. Okay, so this 100 high performance tires are being made by certain manufacturer, which lasted on the average of 21,819 miles. So this average is actually on the basis of these 100 high performance tires. So it is sample mean. And their average is given to be, their standard deviation is given to be 1,295 miles. So it is talking about sample standard deviation. We are going to test the null hypothesis that the high performance tires have mileage at 22,000, and against the alternative hypothesis that they are lesser than that. Okay, so specifically they have mentioned what to select for null hypothesis as well as alternative hypothesis. So we have accordingly we have written our null and alternative hypothesis, and we have written that H0 stands for mu equals to 22,000 and H1 stands for mu lesser than 22,000. Alpha is set at 0.05 because they have mentioned it. After calculating, we have got Z to be minus 1.397. Now you see in this particular problem, population standard deviation was missing. And since population standard deviation is missing, according to this particular note and central limit theorem, this and point estimation, population standard deviation has been estimated by sample standard deviation. So we can do so. Generally, they look like same, but they are not same. Theoretically, they are not same. Ultimately, the value is coming to be minus 1.397. And then since the level of significance is set at 0.05, and since it is a one-tail test, why it is one-tail test? Because you look at the alternative hypothesis. Alternative hypothesis, only one possibility is given, that if mu is not 22,000, then it is lesser than that. So in this, because of that, we are not actually considering the value of Z alpha by 2. We are considering the value of Z alpha. And for, you know that for alpha is equal to 0.05, Z alpha is 1.645, minus 1.645. You can consider this to be 1.645 or minus 1.645 on the basis that if whether your Z is minus your value of Z is coming as negative or is coming as positive. Since our value of Z has coming as negative, say minus 1.397, so we are actually considering this particular value, negative value, corresponding to that negative value. You can ask me, this particular part is the logic is very simple. Suppose since the value of Z is positive, you think carefully, you listen to me. If the value of Z is positive, say negative, and if you compare the negative value with a positive value, always the value will be lesser than that. So that will not be the best analysis. So if the value of Z is coming to be negative, you have to compare this value with a negative value. And therefore, we are considering minus 1.645 and not 1.645. But if the value is positive, then we can compare it with 1.645, not minus 1.645, because every positive value will be greater than that. Then also that will not be the correct analysis. So positive will be compared with positive and negative will be compared with negative. Therefore, since negative value has come, so we are comparing this with a negative value. So we have considered, and since at alpha equal to 0.05, the Z alpha is 1.645, we are considering its negative counterpart, that is minus 1.645, because we have got a negative value. And we see that your Z minus 1.397 is greater than minus 1.645. And null hypothesis, in that case, we do not reject the null hypothesis because it is falling inside the acceptance region. If you consider this particular curve, and if you set this as minus 1.645, then you are getting your value here in this case, in this part. So it is falling under the acceptance region, and therefore you are accepting it. Okay. And since the null hypothesis has not been rejected, there is no convincing evidence that the tires are not as good as assumed under the null hypothesis. So we are actually accepting that indeed the tires are in good quality and they are giving you the mileage on the basis of 22,000 miles as has been expected in the null hypothesis. So these are the two problems which I needed to discuss with you, and they are related to test concerning mean. In tomorrow's class, I am going to give you another perspective of testing of hypothesis through p-value. Okay, and we shall discuss some other testings which are there mentioned in your syllabus. So I hope you have understood what I wanted to say to the class. If I can upload the video in the YouTube, then I shall share with you, and as well as the note. See you tomorrow. Till then, goodbye.